Hi, it's Bruce, and welcome once again to my Colorado Rocky Mountain Lab. Today we're taking a look at a Fluke 8810A digital multimeter. It's a multimeter with 5 DC ranges from 200 millivolt full scale up to 1200 volt DC full scale. And in the 200 millivolt up to 20 volt ranges, you've got 1 gig ohm of input impedance, so it's a high impedance unit. And then above that, you drop to 10 megohms. So that's pretty standard too. This unit, I forgot to mention, also has the resistance option and an AC voltage option. So let's take a look at the AC voltage next, and then we'll do the resistance. The unit right now is reading DC. We're on the 200 millivolt scale. We're feeding in from that Fluke 343A calibrator, and we're comparing to this Hewlett-Packard 34401A. We see right now that the 34401A is indicating that we have 100.005 or 6 millivolts. And we see that on the Fluke we're getting 100.005 to 6. So we're in agreement within a millivolt, a microvolt or so. So that's very nice. We're going to go ahead and go to the 2 volt range. On the 2 volt range, we're getting 0.1 with 4 zeros, which would be correct because we would have 0.1 with 4 zeros followed by a 4 or 5 or 6. So within a microvolt, we are good on this scale. Let's go ahead and take ourselves up to the 1 volt range. And we are reading 1 and 5 zeros on the HP. And we are reading all 9s on the Fluke. So within 10 microvolts on the 2 volt range, we are absolutely comparable. In fact, you just saw it flash there. We're somewhere between all 9s to 1. Just flashed again. Let's go to the 20 volt scale. And we'll put ourselves 10 volts. We're getting 10.0001, and we're getting 10.0001 or 2 volts. Again, very, very close. 200 volt range. Okay, on 200 volts, we're getting 100.003 on the HP, and we're getting all 9s to 100 on the Fluke. At 100 volts, we're within 3 millivolts of agreement. And finally, we go to the 1200 range. I'm reading 100. And let's take ourselves up to 500 volts just to test it. Okay. 500.01, 500.01. So very nice agreement between the Hewlett-Packard and the Fluke on the DC ranges. Okay. Okay, we're connected up AC-wise. We're connected to that Fluke 5200A, putting out 1 volt at 500 hertz, and we are reading 1 volt on the HP. And we're getting all nines with an 8 to a 9. So we're within 10 microvolts of being perfect. Okay, let's try the 20 volt scale. We'll go for 10. We got all nines to a 10 on the HP. 10 volts. We've got all nines with a 8, 7, or an 8, which would put us within the within the lower performance, and we're right there at 7 to an 8. All right, let's take a look at the 200 volts scale. We're going to go for 100 in. Right, we've got 100 within a millivolt, and we are reading all nines and flickering to an 8 on the lower end, so we're right there. And then finally on the 750 volt scale, the highest we can go is about 119 volts, but we'll take her up there and take a look. Right now we're reading 100 with a millivolt, and it's reading 100. We'll take her up as high as she'll go. All right, we got 119.92. We got 119.91. So we're right there. Okay, so AC wise, we're doing a decent job. Let's take a look at the ohms. Okay, we're connected up in the ohms position, and we are reading the 20 megohm scale. We've got 10 megohms coming in off of this resistor stat 2 box, which is a 0.01% resistance box. We're getting a reading of 10.004950 right in there. We'll say 5. 10.005. Okay, so 10.005, which we're actually even lower now. We're reading about 0036, so we'll call it a 4. 10.004 is well within the limits for the resistance checks. We should be between 9.9797 and 10.02. We're 10.004, so well within it, reading it fine. Let's go to the next resistance they call for, which is a megohm. And we go to the 2 megohm scale. And we're reading 999,000 and 910, looks like. And according to this, if we read 999,000.47 to 1,000.53, we're good. We're in between those limits. We're good. All right, let's take a look at the 200,000 scale. So we want 100,000. 200,000 scale. And we are reading 99,993. And if we were between 99,987 and 100.013, we're good. So we are well within that and good. All right, let's go to 20,000. And we are reading 9.9995. And we as long as we are between 9.9987 and 10.0013, we're good. Well, we're well within that. We're extremely close to the exact figure of 10,000. Okay, so let's go to the 2,000 ohm scale. We're going to have 1,000 ohms in. We're reading 0.99993. If we read 0.99987 to 1.00013, we're good, and we're well within those limits. We are reading within, is that, it's 1,000 ohms, 999.93. We're within 7 ohms, something like that. It's really close. Okay, so let's, the next step would be 100 ohms. Okay, I'm checking my lead resistance at this point, and I'm reading 0.038 or 39. So, got to keep that in mind when we go to make these low readings. All right, we're at 100 ohms. We're getting 100.044. If I take the first 4 out of there, we'd be 100.003, which would put us right smack in the middle of where we want to be. 99.97 to 100.03, and that would be 100.00. So I mean, that's, what more can you ask? So we passed the test for resistance as well. So it's a nice looking unit. This Fluke 8810A. This is serial number 2087021. I believe I put a new power key on this one, and it was given a calibration and then tested, but it's a nice looking unit. It's in very decent shape. As you can see. And we've run it through its tests, and you know, outside of a scratch on the front panel here, which when you're looking at it dead on, you really don't see it. You'd have to catch it in just the right light to be able to see the scratch, but it's there. But it's not noticeable, so you're going to like that. With its 1 gig ohm of impedance on the first 3 ranges, you're going to get very low loading on your circuits. You've got 5.5 digits, meaning you're going to see 6 sometimes. So you've got a lot of resolution there. So, nice looking unit. Passed all of its performance testing. We'll include a CD manual with it. So there's really not much more you can ask for. Happy bidding, and we'll see you again.